Today, I'd like to briefly introduce some of the main features of the network traffic analysis solutions on the on the BDS product. What NTA stands for, network traffic analysis stands for. According to Gartner, NTA, network traffic analysis, is a mechanism that used network traffics by monitoring network traffics and use analysis of the network traffics to establish the baseline, and over a period of time can use this baseline to detect these abnormalities. This is one of the very recent development in the cyber defense company used to detect all these potential threat attacks or abnormalities, especially from inside. So Hillstone Networks, this device and this technology has been listed on the Gartner's recommendation list. So that validates our NTA technologies we have been developing. So what NTA stands for and what does NTA mean? NTA actually is a tool to, I just mentioned again, to recap, NTA is the tools that by continuously analyzing the raw traffic and flows and build baseline models to reflect the normal traffic behaviors, and then use this normal traffic behavior baseline to detect the abnormalities of the traffic. So what the Hillstone BDS product or server BDS product is a device, appliance, that has integrated many detection engines inside that conduct threat detection from all angles. These detection engines include some of the legacy firewall detection engines like the IDS and some of the firewall policies based zone-based detection mechanism, as well as the some behavior analysis detection model like UEBA according to Gartner terminology. We have this user behavior modeling inside the box, and also also has this malware family analysis modeling based upon the millions of malware families and samples using machine learning mechanism to build up the detection model inside. And also we have other models like building some technology like DGA detections, like deception technologies and other things. And also network traffic analysis, also one of the major detection engines inside this appliance. So again, this BDS appliance it's a highly integrated device that has multiple detection engines, from static-based legacy detection engines to user behaviors, machine learning-based detection engines, and also the traffic analysis detection engines built into this appliance. And typically, typically the NTA, the BDS the appliance is deployed near what we call the critical assets, which usually is a server inside the corporation. You usually deploy near this corporation. Typically, in the network topology inside the corporation, it consists of multiple servers or groups and host groups, and these multiple servers like a FTP server, mail server, web server, things like that, is connected to the aggregate access switch, and all these access switch are then connected to what we call the second layer aggregation switch, and then going to the internet. So as you can see on page 5, the BDS appliance can be deployed near the critical assets it is trying to protect, which is can be deployed near the access switch or aggregation switch. We can mirror the traffic of the traffic flowing through these switches by tapping the switch port into the device. So from this aspect, deployment of the BDS is very very simple and very less disruptive to the normal business. So it's very safe to deploy this BDS appliance, and it's also very flexible and very effective in capturing traffic and conduct analysis. So how does the NTA solution work? NTA solution on the BDS appliance, basically when you deploy a box, it enters what we call the learning mode first. So during this learning mode, the NTA engine try to monitoring the traffic. It is trying to, from the server, it is trying to protect over a certain period of time. Usually by default is 2 weeks, and this is configurable. Later I will show you in a demo. During the learning period, it try to monitor these traffics associated with the critical assets it's trying to protect and establish the baseline of these traffics. The traffics we are paying attention to include the traffics to and from the server in trying to protect, and also the traffics in and out the internet, and also the traffics between the servers and also other hosts. So the multiple dimensions of the traffics we are trying to monitoring and conduct analysis later. So the granularity of the traffic, since if we want to capture all the traffic, the amount of traffic we're going to capture will be a huge amount. So we do some granularities based upon the entities we try to protect. For example, if the traffic coming between the servers, we try to do every single sessions of flows. We try to record them and monitor them. The traffics in and out of the network, we try to aggregate those traffics because the amount of the traffic in and out of the network, internet, are huge. So it's impossible to capture all of them. So depends on the traffic, where it goes, where it's from, and direction of the traffic. We perform different monitoring granularities. And after we monitor the traffic for the certain period of time during the learning cycle, which is usually the 2 weeks, we enter what we call the detection mode or monitor mode. During this mode, the baseline that is established during the learning cycle is used to check against the traffics between in and out these entities. So if the live traffic goes beyond the baseline over a certain threshold, we think it might be something that the administrator need to pay attention to. That's why we flag a red dot event here, as you can see on page 6, which I also show later in the demo. So the type of traffic we are trying to monitor and analyze, including upstream traffic, downstream traffic, in and out of a particular server, and also the new connections. The new connection, the reason we try to capture a new connection is that usually after the corporation network stabilized, the traffics between the servers, for example, between the FTP servers and the web servers, are usually very stable. If there are some new connections or unknown connections occurred between the servers, that's something we think the administrator need to pay attention to, and we flag a red dot on this, as you can see on page 6, the new connection alert. When this alert happens, administrators can look into this, and if this is a false positive, he thinks he can do several actions. He can ignore this event, which similar event will not be reported in the future, or he can select a not monitoring action, which later the whole flow will not be monitored. And also he can select baseline learning, which he add this particular event or traffic amount back to the baseline learning, because at the background even though we are in a monitoring mode, the traffic is being continuously monitored and the baseline is continuously being updated. So he can add this event back to the baseline learning update so that this will be reflected in the future baseline. For example, if let's say, if during the holiday season, the traffic amount suddenly spike, and the administrator thinks it's a normal traffic pattern or traffic behavior, and he can select, for example, ignore this, or he thinks this might be something useful later, he can do add this particular traffic amount event alert back to the baseline. So later on, during the holiday session, let's say from Christmas season, these traffic spikes will not be flagged as alert during this period. So this is some of details of the traffic NTA techniques we applied in this appliance during development. Actually, this is shows the main features of the BDS appliance or BDS device or BDS system. So we follow the detection attacking threat attacks patterns. Usually, as you know, the modern threat attack or advanced persistent threat attacks is not a one-shot deal. It follows a certain pattern. First, it's to enter the breaching, the phishing and the breaching stage. After breach through these perimeter defenses, he goes into the post-breach stage, which he does some internal scanning, lateral movement, all these activities and CNC activities to identify the target he's trying to steal information from, and eventually he tried to, after identify the target, he would do some other mechanism like credential escalations, brute force attacks, try to get into this the assets or servers he tried to target it and then steal information from. So this is a whole process. It's a continuous process. It can last for days, from days to months. So it's a like complicated process. So to detect these process and defend these threat attacks, we also need to apply, compare with the traditional NG firewall technology, which is just at the network parameter. We also apply multiple technologies. In our appliance is the multiple detection engines that follow through these attacking in progress and try to detect them. If we miss certain stage, we'll try to detect them at a later stage. So as long as we can detect them accurately on one stage, we can break the attacking chain, so throttle the purposes of the attacks, which is the stolen information from the server. So slide 7 shows that this is our defense mechanism on this system. First, we have a detection phases, which multiple detection engine behaviors, detection engines, these NTA detection engines, and also other coalition detection engines. These are all work together in coalition to detect them at the different phases of a particular threat attack. After we detect certain possible, we think that a threat attack occurs, we provide the administrator very comprehensive visibility of the events we detected. A lot of events can occur and can be detected. So it's very important to filter out all those noises among the oceans of the events and highlight it and promote it, what we call the indicator of compromise, IOCs. So these IOCs are those events we think are highly accurate, more severe compared with other events. So that the security administrator has to take care of these things. So after the detection engine flagged, we provide the administrator with this comprehensive visibility of the IOCs and also the traffic itself, and also some other information. So visibility, threat visibility is very important so that the administrator can conduct threat huntings and threat analysis and also the mitigations very effectively. At the same time we provide the visibilities, we also provide what we call the forensic analysis. This includes provide this detailed information of the threat and capture the PCAPs if necessary, and also conduct some threat hunting in conjunction with other threat intelligences and other sources. So after that, these been done, after a security administrator conduct a comprehensive analysis, he can conduct some mitigation actions. This include this, put this on the blacklist and block the certain IPs, take this infected or compromised host offline and re-imaging them and things like that. There are also very important features of this BDS appliance. Since it's deployed in the tapping mode, he cannot, instead of inline, he cannot do the blocking or reset directly. So instead, he will send the events or signals back to the firewalls, which is deployed at the network perimeter. And in conjunction with the firewall, he can block these particular events, particular IPs, and particular flow. So from detection to visibility, the visibility to forensic analysis to mitigation, this is a complete threat attack detection and prevention and action chain BDS appliance can do today. Actually, this page just re-illustrates what I just said. The basic architecture of this BDS appliance, including at the bottom, we have multiple detection engines like abnormal behavior, which is today the popular term called UEBA, and we have advanced threat detection, which is our the malware family and analysis based upon millions of samples and machine learning mechanism. Intrusion prevention, which is the IDS, which is a legacy detection engine. AV, antivirus. Also, we can today this slide will be updated. We can also work together with the cloud sandbox. We have this deceptive, which is honeypot technologies, and also we have other threat intelligence incorporations together. These are the building block of the detection technologies built into this appliance. And based upon these functionalities, we can detect and elevate those IOCs, which is the severe and high confidence, high impact threat events that we think the administrators must take a look and then perform analysis. And also on top of all these, we have what we call the threat correlation engine, which can correlate all these different individual events in the space and time spectrum. So this helps to have a global view. It can correlate all the events together, have a global view. It further increase the accuracy of the detections and also reduce the false positive. And also we can correlate together with the cloud. So this is just some of the screenshots, which I will show briefly later. For NTA particularly, as I mentioned already, we first in the learning mode, we learn and establish the normal traffic baseline and thresholds. And also during the after learning mode, we enter what we call the detection mode. So we can detect the live traffic against the baselines we established and detect the abnormalities. And also after that, we can, after detect the certain abnormalities of the traffic, we can promote some visibilities, comprehensive visibilities to the administrators. These pages 10 just going through a little bit details of what I just mentioned earlier. The ATD is basically one of the detection engine on the appliance. It we are basically using machine learning mechanism to do. First, we do the data mining over millions of malware samples, and we extract the features from these malware samples, and we use the supervised unsupervised machine learning to model all these different families, and then we install this model on this appliance and check against the live traffics. And this model, and also this machine learning model is being regularly updated with the new samples coming in. This is what we call the ATD, Advanced Threat Detection Engine. Deception technology is a honeypot. We have a low interaction honeypot, basically also deployed on this appliance. So the network administrator can just configure some darknet address which normal business would not even touch it. So when the malware breach through this network perimeter and do the internal lateral movement and the reconnaissance activities inside the networks, as soon as it touch this the honeypot port or services, we will flag an event. This is usually very accurate. And also on BDS, we integrated with we call the host-based endpoint service event. We use the the free software from Microsoft, Sysmon utilities to install on the host endpoints to collect window events. And these window events are being collected and sent to the Sysmon server and stored in the database. So when the threat event was triggered in the BDS, we will do according to the event attributes like IPs and things like that, we will conduct the threat hunting inside this Sysmon event database. So this is provide a very comprehensive, host-based, process-based information for particular threat events. This basically just reiterate what I just said. The threat detection phase, we have all these detection engines, and also these detection engines will report multiple, lots of threat events. And from these, we use mechanisms like correlations, like other threat intelligence inputs, and also the cloud collaborations to promote the IOCs out of these oceans of events. And then these IOCs, with all these detailed information and the comprehensive forensic information, are presented to the administrator for analysis, for threat hunting, and things like that. This screenshot, page 14, which I'll show you a little later briefly, basically the screenshot of our device. This I'll just skip it for now. And also our device has a big screenshots which can be projected for example, in the network operation centers and also the security SOC centers to show on the big screen to give a global view and a fancy flashy view of what's going on inside the global network. It's basically a screenshot. I will show you a little later. I will skip this. Server traffic monitoring. This all these screenshots. So basically, again, I want to reiterate what I just said. Since a lot of traffics are can occur between the servers and the internet, and between the servers and the hosts groups inside the corporations, it's very important to define different granularity of traffic monitoring and traffic analysis. We think the traffics, east and west traffics between the servers are critical, so we need to monitor them at a high granularity. The traffic in and out network is not that critical, and also the traffic between the host groups, the machines like PCs, those groups are not very critical. So we basically group them together, aggregate them together, so to reduce the resources consumptions, also reduce the analytical resources that are required to conduct this analysis. So we focus on the traffic surrounding the servers This is very important to notice. Visibility, this I will show you a little later, it's just screenshots. We have the table view, we have this graphic view, things like that. Visibility, there's also visibility. So visibility, again, is very important. We need to provide users and administrators with the comprehensive visibility from all angles, so that he can see the traffic from different angles and and can correlate them together. And sometimes it's very important not to miss certain traffic types and certain applications. The BDS appliance can collaborate with the cloud platform. You know, the cloud platform is very important later, become more important these days to incorporate the threat intelligence informations, to manage the multiple appliance deployment, as well as to conduct a global-based threat analysis and threat features and behavior features, all these analysis and updates. So, for example, if one threat detects at one place we think is very critical and very convincible, we can upload to the cloud, and within a very short period of time, the cloud can push all these signatures in a global base, so that at other locations or other deployment sites, the known all the zero-day, what we call, or near zero-day attacks or new threat attacks can be effectively protected. So forensics is very important in our. We think that it's very important in providing the administrators very convincing evidence. So forensics, we have multiple forensics information. We have the knowledge base. We have the threat hunting capabilities together with the sysmount, which is the host-based one. And also we have visibilities, attacking chain, kill chain presentations. And also we have the PCAP capture if necessary. So this is forensics is very important in convince the administrator that a threat did occur. So we're following this. The slide here is also follow this our technology and detection and prevention flow. Currently, the last stage here, once the administrator is convinced that the threat occurs and the machine has been compromised, so he can conduct the mitigation actions, what we call it. He can send this event to the firewalls. In conjunction with the firewall can be utilized to establish certain firewall policies to block and prevent future attacks and or the abnormalities behaviors from that particular source. So this is a mitigation. So we believe that this threat attack and threat, this threat attacking progress is a complicated and multi-stages. It's very targeted attacking in these days. So again, the prevention and detection mechanism is also need to be following these attacking in progress and form the closed loop, meaning from detection to forensic evidencing, to visibility providing, to threat hunting, and also at the end to mitigate all these threat attacks, and also update in collaboration with the cloud, update multiple geolocation to prevent further attacks at different sites. So in this case, using this mechanism, I think we can close this threat detection, analysis, and prevention, close this loop, so to provide the complete solutions. I think the BDS in this aspect provides a very, very effective mechanism and tools in assisting the security administrators in threat detection and prevention. Summarize our NTA solution advantages. So NTA solution, again, on the highlight is one of the important features or engines on this BDS appliance. BDS appliance itself is all-in-one. What I mean is highly integrated, multiple all-in-one solution, including multiple detection engines, which is NTA is one of the major ones. And then this our NTA solution is very easy to deploy. You drop into the box, you tap into the traffic port, and then you, with the minimum configuration and provision, it can just do its job. After it's a certain period of time, he can detect and flag all these events, and with the comprehensive visibilities. And also after that, after the analysis process, he can administrator can conduct the responses very effectively in conjunction with the firewalls. So this is the slide I have right now. Again, this BDS appliance, the development at the Hillstone networks are continuously enhancing the capability of this device in terms of detection accuracy and also the easy and user-friendly and easy to use user interfaces, and also in collaboration with the cloud solutions and also threat intelligence solutions. So you will see in the future this appliance will be more and more effective and accurate in detecting all these sophisticated threat attacks. Next, I will just do a quick demo. Let's see. Okay, so I will do a quick 15 minutes walkthrough of the main screenshots of one of the devices here. If you get a chance, you can get on a device and play with it. If you have any questions, you can send feedbacks. So this is one of the BDS, the device we have in our office. So our office environment, network environment is quite clean, so it's not many abnormalities here or threat attacks here. But I'll just use this machine to show the point. When you first log in, the dashboard here we call iCenter. Again, this in our coming up release, all these will be enhanced even more, easy to use and user friendly, and the workflow should be more smooth, even more, very soon. But this is the major functions so far. In iCenter, we have the server, 3 main blocks, or we can call it angles to look into this device. One is the server point of view, which is we call the critical assets. The other is the host, we call the computer risk assessments, risk summary. And the other angle is the thread, from the thread angle. So particularly for NTA, for configuration, I'll show you here, we go to object, and of course before that, we must configure the server and the host group we try to protect. Here, I already have some server groups to try to protect. You can do a configuration of the server, add a name, a description, an IP address, things like that. Here, we already configure a few server groups. And for traffic monitoring here, configuration is very straightforward. There are very minimum configuration here. Let's see, only a few parameters. You can leave it all default usually. Just let it go. Drop in the box, turn it on, and let it go. Learning cycle here, default is 14 days, but you can change it longer and shorter. Server traffic monitoring, we usually enable. And the host managing the traffic monitoring, we enable. And these two parameters shows that if the traffic baseline is lower than certain threshold, we just ignore it. We don't learn. Because there are some small traffic, like protocol traffics between the servers. Usually the amount is very slow. The amount is very small. So in this case, we just ignore them. We try to reduce the noises here. So once you configure, which you don't need any configure basically, you can just go by default. And then we click the traffic baseline. So during this learning cycle starts, and the traffic baseline will be showing here. All these server, the address between these addresses, and all these for you. This is just for information purpose. The baseline information. You can see time and then the baseline. This is basically just for showing to the administrator that the baseline is been established during this learning cycle. So let's go back to iCenter. in the server view here, let's go back here. So we have two angles on the server view. We have a thread angle, which are the thread attacks that might occur on this server. We also have a traffic view. Traffic view is what we saw in the slide here. Let's say the last 14 days, right? These dots represent the server. I believe right now the dots, we think the risk is low. That's why the color of the dot is green. If the risk is high, I think they will turn red. So these lines represent the traffic interactions between these servers. For example, between the edge and line, there is some traffic from the edge to line, which are the server names. And the color here, red, represents some abnormalities in the traffic. So we can click this line, go into a different table view. This shows the traffic between these two entities. And we expand this thing so we can see what happened. Okay, move this here. We can see there's a new connection occurs at certain time. As I mentioned, once the network is stable inside the intranet of a corporation, the connections, usually connection pattern between servers are stable, like your FTP server, your mail server, or your file server, things like that. Interactions between your web server, which accessed by the employee, is usually very stable. That has been reflected and learned in the baseline. So if any new connections occurs between these two servers, we think that the administrator need to at least take a look. So we flag this thing. So this, you move the mouse here, you can see what's happening here. How many connections occurs and how many active connections. If many connections occurs, there might be some scanning or some other internal movement, suspicious activities. We think this need to be take a look. And with this particular dot, the administrator can perform this, ignore this event if you think this is okay, and not monitoring anymore, which is just shut down this flow, and or you can add this thing back to the baseline learning, which later future baseline learning will reflect these changes. Let me see. New connections. So mostly we see is some new connections occurs between the servers. Risk, traffic type. Let me see. Oh, upstream traffic. There's usually no data. Downstream traffic. Okay. So we found one, let's say downstream traffic is coming from the server to the internet. So I want to show this to you. So it's HTTP traffic. We can see usually the baseline traffic, let's see, it shows downstream traffic, baseline traffic. It will show you in general, the threshold usually is like 4 meg, right? Suddenly you get 200 meg. 250 meg. So this is something we think this administrator needs to be aware. Like in this Capital One credit card data breach incident, this employee downloaded 30 gigabytes of data. So if we have this thing monitor that traffic behavior, we will see, definitely will capture that significant event. And if the administrator can take a look, it might be able to prevent that thing or track it down in time. Let's see. So let me go back to the iCenter dashboard. Again, I want to emphasize that we have 3 views of this appliance. Server view, which we think we highlighted because we think it's very important. And the computer, which is a regular host, we also think is important. But usually the traffic here are a lot between the hosts. and the whole number of the hosts are a lot more. So we aggregated those traffics. And also we have a thread view, which is we can click it, see these individual thread events. Right now, let's see CNC here. We can go to a table view, see these thread events. So we have 3 angles of viewers on this appliance: server, host, and thread. From any point, like any point from the donut circle, from the table, from anywhere we can click, enter into further next pages, which either display this graphically or in a table view, and also provide more comprehensive forensic evidence here. So there are a lot more features packed into this user interfaces. So I'm not going to go over each individual ones. If you have any, have a device or have a time, you can play with it, and then have questions, you can send us feedbacks. So that's basically what I have today.